Hello, aspiring Java developers. Welcome to a brand new tutorial where we will dive into the exciting world of blockchain with Java. Today, we are going to explore Ethereum and how we can interact with it using a powerful Java library called Web3j. This tutorial is perfect if you are an intermediate Java programmer looking to expand your skills into decentralized applications, often known as DApps. By the end of this video, you will understand what Ethereum is, how smart contracts work, and how to use Web3j to connect to the Ethereum network and interact with smart contracts from your Java applications. Get ready to build the future, one block at a time. Let us begin our journey into the world of Web3 and Java. We have a lot to cover in just 5 minutes. Alright, let us start with the fundamentals. What exactly is Ethereum? Ethereum is a decentralized, open-source blockchain with smart contract functionality. Think of it as a global, shared computer that anyone can use and verify. Unlike traditional centralized systems, it is not controlled by a single entity. At its core are smart contracts. These are self-executing agreements with the terms of the agreement directly written into lines of code. They run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. Web3j is your Java gateway to interact with this amazing Ethereum network. It is a lightweight, highly reactive, and type-safe Java library that allows you to integrate your Java applications directly with Ethereum nodes. It handles the low-level details of the Ethereum remote procedure call application programming interface, making it much easier for you to build decentralized applications. Now, how do we actually connect our Java application to the Ethereum network using Web3j? First, you need to include the Web3j library in your project dependencies. If you are using Maven, this means adding a specific entry to your pom.xml file. Once the dependency is added, connecting to an Ethereum node is quite straightforward. You will typically connect to an Ethereum client, also known as a node, which could be running locally on your machine or accessed remotely through a service like Infura. Infura provides access to the Ethereum network without you having to run a full node yourself. The core idea is to create an instance of Web3j that points to the uniform resource locator of your chosen Ethereum node. This instance then becomes your primary object for all subsequent interactions with the blockchain. It is like opening a communication channel to the decentralized world. With our connection established, let us move on to a practical example, interacting with a smart contract. To do this, we usually need two things: the smart contract's address on the Ethereum blockchain and its application binary interface, or RABI, which describes the contract's functions. Web3j provides tools to generate Java wrapper classes directly from a compiled smart contract's ABI and bytecode. These wrapper classes make calling smart contract functions as simple as calling regular Java methods. For example, if you have a simple smart contract that stores a message, you can load your Ethereum credentials, deploy the contract if it is not already deployed, and then call its setMessage or getMessage functions directly from your Java code. Web3j handles all the underlying transaction signing, gas estimation, and network communication for you. It truly simplifies the process of decentralized application development. As you embark on your Web3j journey, there are a few common pitfalls to watch out for and some best practices to adopt. One common mistake is neglecting transaction gas costs and limits. Every operation on Ethereum costs gas, and setting an insufficient gas limit will cause your transactions to fail. Always ensure you have enough Ether in your wallet and that your gas limits are reasonable. Another important tip is to understand the difference between synchronous and asynchronous calls. Web3j supports both. For long-running operations like sending transactions, it is often better to use asynchronous calls to keep your application responsive. Always test your decentralized applications thoroughly on test networks like Sepolia or Goerli before deploying to the main Ethereum network. This helps you catch errors without incurring real costs. Proper error handling and logging are also crucial for debugging and maintaining your decentralized applications. And that brings us to the end of our quick 5-minute dive into Ethereum and Web3j for Java. We have covered what Ethereum and smart contracts are, how Web3j acts as your bridge to this decentralized world, how to connect to an Ethereum node, and how to interact with a smart contract using practical Java code. Remember, the world of Web3 is vast and constantly evolving. This tutorial is just the beginning. I encourage you to experiment with the code examples, build your own simple smart contracts, and explore the extensive Web3j documentation. Practice is key to mastering these concepts. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java and blockchain tutorials. Your support helps us create more valuable content for you. Keep coding and see you in the next video.